Let's see. I'm going to make sure I'm not on mute. There we go. Up on high. Great. Good morning, everybody. We're preparing today for our first exam, which will be on, let's see, Thursday. So at this same time, you're not going to come to Zoom. You're going to go directly to your exam. I'm going to send out instructions today. I believe I opened up a mock exam for everybody to try. If you have not tried that mock exam, I'm going to go ahead and open it up until about 11 a.m. on Thursday. Make sure you try that mock exam, because what it's going to do is test to make sure all your settings are correct. And one of the things we ran into this morning is if you're not allowing sharing with in your settings, that your share screen part in settings, Proctoring won't let you take the exam. So that is the only problem I've had with it so far with the settings, which is why we do the mock exam thing. And so if you haven't done it, I'm going to go ahead and assign it again to everybody for until Thursday morning at 10 a.m. or let's do 10:30. So you'll have until then to go ahead and take that exam and make sure that your settings are correct. Okay, that was a big surprise. It was the first two people I've had that problem, but we were able to fix it within about 10 or 20 minutes. So if we just fix it now, we won't have to worry about it. Okay, so the exam is over chapters 1 through 7 only. Okay, and so we've got a lot of material in these chapters 1 through 7. And so when we look at what we want to do is to help you study, use the homework as the style of questions I'll be asking. It's going to be multiple choice. It's going to be approximately 30 questions. It's either going to be 25 or 35 or 30. I'm still finishing up the details on that one. And so there will be, about that many questions equally spread over the 7 chapters. Okay, so one way to study is to, look at your homework. What did you get right? What did you get wrong? And try to figure out why. The other way to do it is also to go to either Top Hat or to Canvas and look at what I call my 3 goals slides. Okay, so in each of those, they have the 3 goals that are most important about that chapter. Okay, and so there'll be 3 sets of slides, one for each of those goals, and it'll explain each of the goals in detail. Now notice that's most of the review. Most of the material we did, but those are the things that you really need to know to help you, answer the questions correctly. Okay. Is there a review under Files, Resources, Canvas? Yes. Oh yeah, there is a review under there. It's a review for this class for chapters 1 through 7 particularly. And I'm going to actually go over that today in class to remind you about a few things there. But I also wanted to draw your attention to, in fact, I'll pull up the chapter 1 goals. The goals slides are under resources. And then there's slides/goals. And so what I'm going to do is I'm going to pull one up and share the screen and show you what I mean by how that works here. I'm going to share my screen with Chrome Files, share right here. And so what you'll see here is the way it structures a little bit differently. I have 3 things that I'm going to talk about. In this particular one, we have electrons and types of bonds, Lewis dot structures, and hybridization. Okay, so those are the 3 most important parts of chapter 1. Make sure you know all of these. Okay. No, the mock exam should be open right now, and you can use it until 10 a.m. on Thursday morning. Okay. So for example, on this one, we're going to talk about Lewis dot structures because this is the goal number 2. And so it goes right into the Lewis dot structures. What are valence electrons and where to find them? Okay. Remember, also refer back to how I explained Lewis dot structures in class, because you don't need to memorize this. You can look at the periodic table. And there are you can see that on the periodic table in group 5 right here, 5A, all of those elements have 5 valence electrons to deal with. And so that you can have it. Okay. Okay. So let's see. Yeah. So let's see. I have a question about proctoring, and yes, it will be On Thursday, you go ahead and you do not come to Zoom. You go directly to Top Hat, and then there should be available to you when you log in exam 1, A, B, or C, okay, depending on where you have. If you have an ODS accommodation, your time is already preset in that. You'll have that time and a half to do that. And then what's best to do is try to log in pretty close to 11 o'clock. And so you have plenty of time to do it. You'll have the class time to do it if you don't have an accommodation, and a little bit more after that if you do. It'll ask you when you sign in for a picture ID, go ahead and hold up a picture ID. It can be your driver's license or your school ID. Both are acceptable. Sometimes it'll like say that's not you because you're wearing glasses on your ID and you're not wearing glasses. So kind of try to be wearing the same kind of eye gear that you're wearing when you have it. Then what it'll do is it'll ask you to scan the room right here. And then what you can do is also hold up your 2 pieces of scratch paper. Okay, it might not remind you at the end to hold the scratch paper up again to show me that they're okay, that they're just scratch paper and you're not writing down answers. But if you forget that, go ahead and just email a picture of them to me after the exam. Okay. Now, the thing is, it's being proctored by artificial intelligence. So nobody will chime in and yell at you or anything like that. Occasionally the program will kick you out for weird movement. And no, the test is not open notes. It is, yeah. All right, so let's see. Occasionally it'll peg you from movement, but that's okay. Go ahead and log back in and complete it. If you get flagged by the artificial intelligence, what's going to happen is I'm going to review it, look at what the behavior was. And then if it was something normal, like, staring off in the distance, or, you have a nervous habit and that kind of flagged it, I'll take that into account and it shouldn't be a problem. But if you're opening up books and downloading stuff on your phone, that shows up, and I'll definitely have to have a conversation with you. But other than that, nobody's ever going to see that video unless you get flagged as suspicious by the artificial intelligence. So there should be no worries, but just keep in mind that I could review it if it comes up as suspicious. Okay. The exam is going to be multiple choice. There's the periodic table is at the beginning and end of the exam. It's the departmental one that everybody gets to use. So I want you using that one, not one of your own, because that way everybody has the same one. And then now you can, once you show your empty paper, as soon as your exam starts, write down a couple notes like trends or something that you didn't want to forget, and that's okay. But you just need to show me that at the end. Okay. The computer will do all the monitoring. You must have a working webcam on whatever device you're taking the exam on, and then it'll do it all through the computer. Also, what I've done is I've taken out the audio recording because it seems to streamline the process a little bit, but I can still, it'll still tell me noise levels and stuff, but it doesn't actually record you, making disparaging comments of me while you're taking the exam.
I have a quick question.
Yes.
So when we did the mock exam, it didn't like ask you to do like the ID or take a scan of the room or
Oh,
anything like that.
okay.
Should it?
Yes, it should. Let me,
And the second time I took the mock exam, it just took me to the exam and like just answered the questions. But the first time it had me go through all the steps to make sure all my systems were working. So I'm not sure if that was correct either.
well, once you get all your systems working, it should be that. Let me unassign
Okay.
it and set up the settings again, because I think what happens is sometimes when I set up the mock exam, it needs to be monitored. It needs Proctorio. It needs to be audio recording, video recording, tabs verified. Yeah, so all of that is correct. So yeah, it should go through the setup the first time you do it, but it doesn't necessarily go up the setup every time.
So it's okay that it never asked for my ID though? I should still be good to go?
It should have asked for your ID. Let me double check the settings here. Verify desktop, verify video. Where is, oh, wait, hold on. Oh, it's not on custom, that's why. Record video, record room, screen, disable printing, close open tabs, force only one screen, verify video, auto check ID. There we go. That's the right one. Block downloads and note tabs. All right. So that's what it was. The setting got changed from the last time I did it. So there we go. So the one I'm going to put out now is going to have from now until tomorrow at 10 a.m., 10:30 a.m. I'm sorry, Thursday at 10:30 a.m. And you can go and make sure that all your settings are correct. So when you have the settings correct, it'll tell you that, and it'll again, the most common setting that I have is when you don't share screen, share screen set up on your settings. That was the last thing that did it. Okay. Let's see. Just to clarify, you will not need a calculator. That is true. Proctorio is free. And so all you have to do is download it onto Chrome first, and then it's actually technically part of Top Hat as far as the actual data services for Proctorio. So you already have that as part of your Top Hat. Okay.
I have a question. So I took the mock exam last night and it didn't say anything about the Proctorio or anything like that. So does that mean that it's already set up in my computer?
If it didn't ask you about it, then probably so. Proctorio is used by several of the other professors, so it might not be there. But if you did try to click on the mock exam, it looks like it takes you to go to the download right there. And so, yeah, you can just Google it in Chrome and go to the official Proctorio page to download it. Don't download it from anywhere else. Again, it's free. It'll fit in. You'll have to restart Chrome. But when you do that, it goes ahead and when you restart Chrome, that will give you everything you need.
Mine never had me download anything either. So I'm thinking it's just a part of it when you got the Top Hat thing. Would that make sense?
No, it would have to. It's a plugin in Chrome. So it's definitely that. You might have downloaded it last semester when you used, if you've taken this course before, or another professor who had.
I've never used it before. I wonder, I don't know why.
Okay, well, double check the mock exam, make sure that you have it there. You can also just search your computer for it too, I think.
It won't let you take it if you don't have it, right?
Okay.
So that's how we.
No. Yeah, it should not let you take it if you don't have it. Okay. So what I will also do is I'll be sending out an email today. It's about, all the different things you should do. The recommended procedure is you get ready for the exam. You go ahead and shut your computer down, reboot it, and then have only Chrome open. And then at 11 o'clock sharp, it'll start to, you just go ahead and refresh the screen, and then the exam should pop up there. Okay, so you should be assigned exam 1A, 1B, or 1C, depending on where you are in the alphabet. I scrambled them, so I don't know which one you're going to get yet. But then you'll go ahead and take the exam from memory, no notes. You may have 2 pieces of paper. You don't need a table, an elemental a periodic table of elements, and you don't need a calculator. So, and then just go ahead and answer all the multiple choice questions the best you have. It records your response as you click, so there's no actual submit button. I think there's a hand-in test button at the end. But if at any time when you're done, you can just close the program and it saves all of your results. Now, if you get kicked out for some reason, I can let you back in. All you have to do is email me and I'll let you back in, and then you can continue with your thing. If you get kicked out more than once or twice, there might be an issue with something in the background or something about what you're doing, and I'll check the AI for why it's trying to kick you out.
Professor.
Yes.
And just to clarify, I know when I did the mock exam, it made me save every question when I was going through.
Okay. So. Okay, maybe I didn't think there was a save button for each. I thought it saved it as you go, but whatever it asks you to do, please follow the instructions. So for questions that we have to order things, do you get partial credit if we order them some of them correctly and some of them not. Yes, yes, you do. Okay, so any other, let me go ahead and stop sharing the screen. Any other questions about the mode of the exam, how we're going to take this exam? Okay, again, look for instructions. I usually send out the day before, and so I might send it out tomorrow, but I might send it out today just so you have enough information. And again, go ahead and I'll send out something that's saying the mock exam is open and correct. So you should either have Proctoring or be prompted to use it. And hopefully it'll ask you to use your ID. So you get used to that. And when you flash your ID is also the time you show me your scratch paper. What would you say is the hardest exam? Physical chemistry final? No, for our class, I think that one of the hardest topics is the chirality. But overall, the fact that, you know, everything kind of builds on each other. I think the first one, just getting the anxiety of how we're testing out, this first one probably might be the most anxious test, but we're just going to keep adding on additional information. And so you're going to start to see patterns and similarities. And so I think maybe this one might be the most anxious test, but the longest test is going to be the final. So, because that's a whole, that you're allowed 2.5 hours. And I think it's 60 questions or 75 questions. So you'll be exhausted after that one. I'm exhausted just writing it. So, all right, other questions? Okay, can we have a bottle of water during the exam, or will Proctoring kick you out? Proctoring will not kick you out for a bottle of water as long as it's on your desktop when you scan your room. So be prepared with everything you need, couple pencils and scratch paper, and then go ahead and do the room scan, and whatever's there, it counts as there. Now, if the water bottle just pops up somewhere in the middle of it, it's like, okay, wait a minute, what happened? It might kick you out for that, but just have it on the table when you're doing that. Glass of water, cup of tea, whatever, just keep it in, you know, that initial scan. And again, Proctoring really doesn't yell at you or anything like that, so you don't have to worry about that, you know, and there's nobody watching you, it's just AI. So you should hopefully have a little bit less anxious about that as well.
And if you are kicked out, you said it's easy, you just log back in, right?
Yeah, email me and I'll make sure you can log back in.
Okay.
Yeah, and so sometimes it'll kick you out a couple times because of a certain behavior, and I can tell you what that behavior is. For example, I had somebody get kicked out because there's a little button at the bottom of the screen about share, and they kept trying to hit the share button when it's, if you want to get rid of it, you have to hit the hide button. And so they kept getting kicked out for that. But that's just one way to do it. Okay, I have pets. No, pets usually don't do it. Somebody looking over your shoulder definitely does. It pops up on the AI as suspicious. If you look like you're talking to someone, like turning off screen and your mouth is moving, that kicks you out. If you try to do some other screen, it'll kick you out, you know, a bunch of stuff like that. So, you know, just become prepared to take an exam like you would normally come in class, and just go ahead and take the exam. Okay, so what if we talk out loud? That's fine. You can talk through the whole thing as long as, you know, you're not looking off screen like you're looking at someone. You can you know, talk your way through the exam saying, oh, it can't be that one, it has to be this one, or that's okay. And, you know, you can move around a little bit, but don't leave the screen or don't try to pivot away from the screen. That usually kind of flags it too. Okay. All right. Okay, so I hope that part isn't giving you too much angst here. Let's talk about the different topics that are important. Okay, so you have a couple days to study now, and so what I think you should do is go back and look at the homework you got right and wrong and start there. Go look at the goals slides either on Top Hat or on Canvas, okay? Do you understand those top 3 goals? Now, if you don't, those slides have the, just explaining those particular goals independently. And then you can maybe go back to the videos online and listen to the way I speak about those particular things by looking at when it was in the lecture. So you can use the lecture schedule to kind of figure out when we talked about it in class. Okay. So after that, then I would try to go back and do the homework again, to see if you're getting it right again. And then that should give you an idea of the last few things you need to study. Okay. But I have a review on Canvas, but I'm going to walk you through it and give you some highlights of things that we can use. Okay. So any questions before I head off to the review that's available on Canvas? Okay, so I'm going to go ahead and share my screen while you guys are typing. Let's see. All right, so you should see our organic chemistry review. I'm going to go ahead and move my display over here. Nobody's needing into the room, and chat's still on. All right, so Chapter 1. Chapter 1 is all about what is the chemical bond and the nature of the chemical bond, okay? Yes, just go ahead and email me if you want to schedule office hours, okay? Yeah, between now and the exam. I have some time today, tomorrow afternoon, and Thursday morning. Okay, so the thing about this is it's all about where the electrons are. You need to know how many electrons you have to give you the number of bonds you're going to have with your elements. You also need to know how many electrons you have to draw a Lewis dot structure. And where the electrons are tells you something about the shape of the molecule. Oh, well, there should be a 1 through 7 chapter review as well as the 1 through 8. Oh, okay, I just downloaded the wrong one. There should be a 1 through 7 chapter review on Canvas as well. Let me double check that. Resources. Yeah, I just downloaded the 1 through 11 by accident, but 1 through 7 is also on Canvas and is also available to you. Okay, so chapter 1 is all about the shapes, and that tells you how many electron zones you have, tells you where the electrons are. Where the electrons are then tells you where the bonds have to be. Electrons take up space, but they don't change they don't dictate the molecular geometry. All the bonds dictate the molecular geometry. Okay. Now, when you have your 4 electron zones, you have a tetrahedral. When you have 3 electron zones, you have the trigonal planar. And when you have 2 electron zones, you have that linear. Okay. Now, note, each of those shapes also correlates to a type of hybridization. The tetrahedral is sp3 hybridized. The trigonal planar is sp2 hybridized. And the linear is sp hybridized. Okay, so those number of electrons, molecular shape, and electronic zones all correlate to hybridization. Okay. So then we also have a number of functional groups to deal with. And notice that we looked at these specifically when we were looking at Lewis dot structures, because we wanted to show all the different varieties of where those electrons are. Notice these are, if you add the Lewis dot structures, the lone pairs to these, you're going to start to see something about reactivity and why they're different and how they react. Of course, we have a bunch of different things. We're going to be getting into the alcohols soon and some of the reactivities of that. And then we're going to cover the reactivities of all of these different functional groups by the time we get to chapter 16. Okay, chapter 2, acids and bases. Okay, and what's most important about acids and bases is we have 2 concepts that we have to use. One is the Lewis acid-base theory, and the second one is the Bronsted-Lowry acid-base theory. In Bronsted-Lowry, we have organic molecules that are transferring protons between each other, and we have to know the pKa, or the acidity constant, the log of the acidity constant. And one of the things we need to know is we need to, in general, know some of these pKa's. You kind of memorize them. All the strong acids right here are less than 0. That's the most important thing you have to know. The next most important thing you have to know is acetic acid is right around 5, 4.75. And then you need to know phenol. And the reason we need to know phenol is that it's got conjugation making it more acidic than other things. And that's why we need it. And then water and alcohol are about the same. And then we're going to talk about how hybridization changes acidity in the carbon-hydrogen bond. But you need to know those 3 ones. The alkynes are at 25, the alkenes are at 44, and the alkanes are in the 50s. Okay. So those are ones you want to know. Now, memorize if you have to, but you want to know. The other concept we learned here is that if something is a very strong acid, when it loses its proton, that conjugate base is a very weak base. So it's equal but opposite. Strong acid becomes a weak base. A weak acid becomes a very strong base. So that means that all of our alkanes and alkenes and alkynes right here, once they remove a proton, they are really strong acids, and they will, really strong bases, and they will try to steal hydrogen from anything below it on the list, okay? Because it so wants to have that hydrogen there, it'll steal it from everything else below it on the list, okay? The rough number, the whole number, like 5 for acetic acid is just because you'll be able to rack and stack anything you're asked if you know that whole number. Okay, so Lewis acid and base. You know what the Lewis acid and base is. A Lewis acid is something that can accept a pair of electrons to form a new sigma bond. A Lewis base is anything that already has a pair of electrons that it can reach out and create a new sigma bond. So what that means is the Arrhenius definition still works because the water is the Lewis base and the hydrogen of the strong acid is the acid, the Lewis acid. In Bronsted-Lowry, it's exactly the same thing. We're still transferring a proton, but now we don't have to have water. And so the Lewis acid base definition will work even if there's not a proton transfer. We can have a Lewis acid base reaction where no proton is transferred, just electrons are being used to create a new sigma bond. Okay, so those are the key things about the acids and bases in our system. Okay, excuse me. All right, questions on acids and bases. Okay. So our sp2, sp3, and sp hybridization told us something about the shape of the molecule. It told us something about where the electron zones are, but it also told us something about the acidity. The sp, which is more S character, is more acidic because those S electrons are held closer to the nucleus, and therefore it's easy to give up. That's why that sp hybridized, that alkyne, is more acidic than the alkene, which is sp2 hybridized. So it's 33% S. And then by the time we get up to the sp3 hybridized, it is the weakest acid of them all. So hybridization also controls acidity. Now remember, there's 4 things that control acidity, right? We have the size and nucleophilicity of the atom, an inductive effect, resonance or effects, and or conjugated effects. So those effects also control the acidity. All right, so then we did a big chapter on nomenclature. Okay, so now we can name anything we have, anything we find, by first finding the highest priority functional group and then naming everything from there. But we also want to make sure we know some of these common names for the alkyl substituents. Okay, Okay, so knowing those common names for those substituents makes it easier to use. Then we need to know our rules in order, okay? Highest functional group, longest chain, branches, numbering systems, 2 or more identical things. Know them in order. Know what our stereoisomers are. Should we have a question here? Should we focus on induction and resonance when looking to the acids or pK? No, I just want you to know that induction and resonance will show up in some questions where it's like, well, of these two acids, which is more acidic? And you have to look, oh, does it have a resonance structure or does it have an electronic drawing group on it? Because those two things are going to change the acidity of the materials. And so you'll be able to say, oh, acetic acid and acetic acid with a halogen on it. Oh, which one's going to be more acidic? Well, it's the one with the halogen on it because the electronic drawing group. Does that answer your question? Okay. So don't forget your E and Z and your RNS uses the same priority rules, but they're slightly different. One is, cis and trans or cis and trans like. The other one is the rotation, clockwise for R, counterclockwise for S. Now also, when we look at this, don't forget to use all 4 parts of your name. The parts of your name include the substituents, okay? So that's everything in the prefix, everything before the prefix. The prefix is the number of atoms, number of carbon atoms you have in that longest chain. The infix tells you your single bonds, double bonds, triple bonds, and the suffix tells you that class of compound. So use all 4 parts of that name, all the substituents, prefix, infix, and suffix, to name every compound. And if you use them in order, you should be able to name and or draw any compound you see. Okay. And there's our an, ene, and ein. Remember that an, ene, and ein also changes with hybridization. Those single bonds, only single bonds, have to have sp3 hybridization. Double bonds have to have sp2 hybridizations and an available p orbital to make that pi bond. And then alkynes have to have 2 available p orbitals, which means it has to be sp hybridized. Okay. And then our suffix changes the end of the word depending on the class of the compound. Remember things like amine just tacks the word amine at the end, but these are the suffixes that are changing the names: aldehyde, ketone, alcohol, and carboxylic acids. All right, questions? Yes.
Okay, so I would always get confused with the nomenclature when we would do the homework. When we're trying to figure out a name of a compound, is it always going to have like the prefix, infix, and suffix, or does it just depend?
Every compound has the prefix, infix, and suffix, yes.
Okay, thank
They
you.
don't always have substituents. So for example, dodecane, right? Dodeca is the prefix. That's telling you you have 12 carbons. Ane, the infix, is telling you have no double bonds. And the E at the end tells you you have no other functional group. So all 3 things are present. Okay?
Okay, thank you. That makes sense.
So you will find all 3 parts in every name. Okay. And then if you have any substituents, that's going to be tacked on to the beginning. Okay. Know your degrees of carbon. Primary is only 1 other carbon bound to it. Secondary, tertiary, and quaternary depend on how many other things are bonded to it. So know that and be able to recognize primary, secondary, and tertiary carbons. Okay. Now we're going to get into using those and some other reactions here pretty soon. So it's important to remember. Alcohols follow that suit. If the carbon is a primary, your alcohol is a primary. If your carbon is a methyl group with no other carbons, then it can't be, then it has to be what we call the methyl alcohol. Then we have secondary and tertiary. We cannot have a quaternary alcohol because the carbon already has 4 things bonded to it. So that's why we only have primary, secondary, and tertiary alcohols. Of course, what confuses that is the fact that amines are backwards. Amines care about how many carbons are bonded to the nitrogen. So in both amines and amides, it's how many amines, how many carbons are bonded to that nitrogen. So in amines, it's just each carbon you add goes to primary, secondary, and tertiary. In the amides, the first bond to carbon is always the carbonyl. And then anytime you add additional carbons to them, they turn into the secondary and tertiary. All right, questions on nomenclature? Yeah. Several people have said that if you do nomenclature quiz question search on, there's a couple different places where you can just go and practice on somebody else's website. I haven't really found one I really like, so I don't really recommend one, but I've had several people say that they found them quite easily, and they're free and they're easy to use, just to help you get them in order. Okay, so that takes us up to chapter 5, alkenes. And we learned some stuff in the alkenes. Is the first thing we learned is that hydrocarbons aren't very reactive by themselves. All we do is burn them, right? But alkenes, we can do chemistry with that pi bond. And the chemistry we do through that pi bond is we do what we call addition reactions. We add things across the bond. And so one of the things is going to be on one of the carbons and one is going to be on the other carbon. So if you're adding HCl, the H is going to be on one and the Cl is going to be on the other. If you're adding water, OH is going to be on one and the H is going to be on the other. But there's a rule for that. Remember, the hydrogen is always going to go on the side with the more hydrogens. So don't forget Markovnikov's rule on this, okay? Now, the one that breaks that rule is the hydroboration, okay? Hydroboration is backwards. So the boron actually goes on the one with more hydrogen, okay? So don't forget that. And when you add a halogen, you know, Cl2 or bromine 2, you get one halogen on each side. So those are the reactions we saw in alkenes. And just think about it. Okay, this is an addition reaction. I'm going to add something to each of the carbons in the double bond. Okay. Now, let's go back to hybridization again and acidity. Hybridization and acidity is also found in this chapter. The alkane, which is sp3 hybridized, is the least acidic. It has the highest pKa value. Followed by the alkene, which is around 44, followed by the alkyne. And again, it's that hybridization. The more and more of the S character you have, which is the small spherical shell that's closest to the nucleus, the more easily it can stabilize that negative charge, which means that makes that proton more acidic. Okay, so they're all less acidic than water, but they have series based on their hybridization. Questions on alkenes? And I think we learned a little bit about stability of alkenes based on their heats of hydrogenation, sorry. All right, then we moved on to different kinds of ways to look at mechanisms. Now, one of the best ways we have to look at a mechanism is the energy diagram. If you have one step, that was a one-step reaction, and all you have to worry about is all the different components that are available to us on this energy diagram. For example, knowing what this state is, this is the activation energy. You have to have that much energy to get the reaction to go. You only have one transition state. Remember, that's not a compound. It's when you're making and breaking bonds at the exact same time. And then the difference in energy from beginning to end. That's the heat of the reaction. If the potential energy of the products is lower than the starting materials, you have an exothermic reaction. If it's higher than the products, you have an endothermic reaction. Now, when you go to a two-step, you actually form an independent compound known as the intermediate. They tend to be very reactive. So we have this intermediate. It does chemically exist. We can see it. And it has to go through a second transition state to go to products. So in our one-step reactions, we have one hump. In our two steps, we have two humps. But we form that intermediate. Notice they each have this transition state right here. And that transition state is this mythical time when a bond is making and a bond is breaking. Okay, you cannot isolate the thing in the transition state. Okay. Questions on energy diagrams? Okay. So we also learned that in a mechanism, they're not as complicated as we thought, right? Because there's only 5 things we're looking for when we see it, okay? And those 5 things are pretty logical. We're either going to add a proton, okay? Now, when are you likely to add a proton? Well, if you have an acid catalyzed reaction, you're probably the first step is going to be add a proton, okay? Now, the next thing is to take away a proton. If you have a base catalyzed reaction, you're going to take away a proton, or maybe you formed something, but it was still charged. It has a positive charge. The easiest way to lose a positive charge is to take a proton away. The next thing that can happen is we're going to have an electrophile react with a nucleophile. So an electrophile is also known as a Lewis acid, and it is going to react with our Lewis base to form a new covalent bond. So that reaction between that electrophile and nucleophile is that other reaction we have. Okay, so think about, neutral species or something with a negative charge coming in and reacting with something. The other thing we have is rearrangement. We have a rearrangement, especially in the case of carbocations. Okay, you're always going to go from the less stable carbocation, the secondary carbocation, to the tertiary carbocation, and you can do it 2 ways. Move a hydrogen over 1 with its electrons, or move a methyl group over 1 with its electrons. It'll only ever do it once, and it'll only move a hydrogen or a methyl group. If you have a ring, that means that you can actually move what looks like more than a methyl group, but it's allowing you to open the ring to get a less ring. Where are electrophiles and nucleophiles talked about? They are talked about first in chapter 6. Chapter 5 or 6, where we're talking about these energy diagrams. Okay. So the last pattern we have for us is we break a bond to form a stable molecule. So this is also looking at carbocations. We actually can form a carbocation by having something leave first to make that carbocation available to us. Or imagine that you have something leave like a chloride ion leave, and that becomes a stable ion or molecule. Okay. The other way to break a bond to form it is when, that's the major thing you're going to see. All right, now, because carbocations can rearrange, and we know that it's going to go from a secondary to a tertiary, we just need to know why. And the reason is that the tertiary carbocation is more stable. Remember, by having this positive charge here, it can pull electron density in from these 3 methyl groups, making it less of a positive charge. The less of a positive charge, it's going to be more stable. Here in the secondary, we only have 2 available to us, so it's not as stable. Here we only have 1, and those are not stable at all. In fact, we rarely see them in solution. We only see them in other really exotic situations, and we never see the methyl. Okay, so it's all about that stability and why it's more stable. Okay, so that's chapter 5 under mechanisms. Thank you. The next thing we learned was, actually, we learned chapter 7 first, but I'm going to leave chapter 6 here. Is talking about stereoisomers. And remember, stereoisomers are isomers that are just different in space. And we had 2 sets of those that we were looking at. We were looking at things that were non-superimposable mirror images. And we always have 2 of them. Okay. And those are enantiomers. And so these are the ones that are R and S and only have 1 stereocenter, and we can see them as mirror images. And then we have to assign them by looking at clockwise or counterclockwise. If you assign your priorities correctly and it's clockwise, it's R. If you assign your priorities correctly and it's counterclockwise, it's S. You can use either hand to do the assignment. It doesn't matter, as long as number 4 is always on your wrist. You can do either hand to do that assignment. Okay. Now, when you have more than 1 stereocenter, that means that you can have diastereomers. Okay. And the number of diastereomers you have depends on the number of stereocenters. So it's going to be 2 to the whatever the number of stereocenters are. So if you have 3 stereocenters, that means you're going to have a total of 8 possible diastereomers. But remember, Diastereomers don't always have a full set, because if you find a mirror plane in one of the sets of diastereomers, that turns it into a meso compound and it becomes achiral. Okay, so diastereomers are a little tricky because you have to draw them out and look for that mirror image, or look for a plane in a ring or something. And if you see a mirror image in that plane, you have a meso compound, and it is not carbon. It's still a unique molecule. And so you end up with 3 different unique molecules, but you don't have 2 pairs of enantiomers. You have a pair of enantiomers and a meso compound. Okay. All right, which brings us to chapter 7. Chapter 7 is our first chemistry, and we talked about nucleophiles a lot in this chapter. So you can think about what a good nucleophile is. A good nucleophile is something that has a negative charge on it, okay? And something that's big, like bromine and iodine, okay? Think about it. Those are nice, stable electrons, and it's a big electron cloud. Sulfur is bigger than oxygen, so sulfur as an anion is also a very good nucleophile, and oxygen with a negative charge on it. Those are all good nucleophiles. However, if we take that oxygen negative charge and turn it into a carboxylic acid anion, or have it be delocalized over 2 or more oxygens, it loses some of that nucleophilicity and it becomes a moderate one. So in the case of this, we go from oxygen negative here to acetate type ions. Because it's shared over 2, it's not as nucleophilic, and it's a moderate nucleophile. And notice the small anions of chlorine and fluorine are less nucleophilic than the large anions. Okay, so keep those in mind. Now, sulfur is big enough that it can be neutral and be a good nucleophile, and nitrogen is now in that moderate nucleophile section. Notice both of those are neutral species. Okay, all the good ones have negative charges on them, and 4 of the moderate ones have negative charges on them. But then the sulfur and nitrogens can be moderate nucleophiles because of their lone pairs, even though they're neutral species. Okay, and then we get to the poor ones, which are going to be the neutral oxygen-containing systems. Now remember, the reason that they are still nucleophiles is they have those lone pairs. Those lone pairs can be used to reach out and make a new sigma bond. But because they're on oxygen and because they're neutral, they are poor nucleophiles. So we need to know these trends, because that's going to tell us kind of which mechanism we're going to follow. Because if it's a good nucleophile, it can do substitution reactions. If it's a good base, it can do elimination reactions. And so, in fact, many of them are both and will have competing reactions. All right, so in our nucleophilic reactions, what you're attacking with in your alkyl halide, your halide leaves, what you're attacking with controls the product. You can make an alcohol with water and or the hydroxide ion. You can make ethers with an alkoxide. Sulfurs make thiols and sulfides. Iodine can actually displace another one and create an alkyl halide. Ammonias create amines. Waters can create alcohols after removing of a proton. Alcohols can create ethers after removing a proton. Okay. So, and then to figure out which is which, we learned also that if you have a very strong base, that you can actually do elimination reactions. Okay. And what we saw from there is that look at your system. Anything that's a methyl or a primary is probably going to do a substitution reaction with any nucleophile. Okay, as long as they aren't very strong bases. If you can form, if you have a very, very strong base, it can do an elimination reaction. Now, when you get to secondary, you actually can start doing a little bit of SN1 if it's a good nucleophile in a non-protic solvent. But if it's a poor nucleophile in a protic solvent, it can go through that carbocation intermediate. And tertiaries almost always go through a carbocation intermediate. Okay. So that is chapters 1 through 7. And a peek at 8 looks like we're doing making of alcohols. Okay. So questions about that. Okay. And remember, you know, if you're not really sure where to start, go to the goal slides on Canvas or Top Hat and say, okay, what are the 3 goals on here? Yes, I understand that. Okay, I need a little help with that. And yes, I understand that one. And then that'll give you a good place to start and map out. In fact, maybe kind of making a table of all the different goals and then doing a few problems on each of those types of things, making sure you understand how and why. All right. So what I'm going to do now is I'm going to open it up for questions, and then I can just answer questions until everybody is happy. Well, I'm sorry, everybody is satisfied. There's a hand raised.
Okay, so I have 2 questions. So if you have a molecule that has an alkene and an alkyne on it, and let's say the alkyne is at the end and the alkene's in the middle, do you start numbering from the alkyne since it's at the end?
Yes, you want to number it so that whatever your infix is, you know, so you have 2 infixes, so you get to choose by whichever has the lowest number starting that, right? So if your alkyne was 1 carbon in and your alkene was 1 carbon in, then you try to find a substituent to tell you. But if the alkyne's at the end, that means your alkyne carbon can be in the number 1 position, which is going to be your lowest position. Yes.
And if you have a functional group or like a methyl group, the functional group will take priority over the methyl group, correct, when numbering?
Correct.
Okay.
Yeah, well, if it changes the name of the molecule, yes. Yeah, if it's just a substituent, then you put them in alphabetical order.
But as far as the counting goes, like if there's an alcohol group, the alcohol group would be 1.
Correct.
And then,
For as close to 1 as possible, yes.
Okay, got it.
Yeah. Let's see, I have a couple questions in the chat. And then I have 2 hands raised as well. So let's see, does the exam have a time limit or the full class period? Yes, you have the full class period of 80 minutes. Unless you have ODS accommodations, then you have your time and a half. What's the usual grade average on the exam? The raw score is different than the actual average. This class, the way I've taught it online for the past 3 times, I usually get between a 75 and a 77 average on this exam. So I think that that's a really reasonable expectation to be somewhere in that range. And yes, there usually is a curve. The raw is a little bit lower than that. And so I usually kind of get it up to between 75 and 77 based on what other people have done. All right, I have a hand up.
So alkynes, alkanes, and alkenes are obviously all organic compounds, and they're differentiated by the type of bond, right? Because like alkene's triple, alkene is double, and then alkane is single, right?
Correct.
And then when a hydrogen proton bonds with them, they become an acid.
Okay, so the hydrogen itself is the acid, is the proton being transferred from there. And you can think of the pi bond, the cloud there, as the source of electrons. So imagine you have just a double bond, right? And so that you have those electrons in that p orbital, those are going to act as a Lewis base. And those are going to be the electrons that are going to reach out and make that new bond with the hydrogen. Does that answer the question?
So the electrons attracted by the p orbital are
the electrons in that pi bond, the p orbital, are the ones that are going to be used to make the new sigma bond with that hydrogen coming in.
All right. Okay. Thank you.
So look at it as a Lewis acid base thing, and look where the electrons are. So where the electrons are, that's going to be our Lewis base, and those are the electrons that are going to come out and make that new bond. Okay, so it's the same thing as electrophile, nucleophile. The hydrogen is the electrophile. It's looking for electrons. The nucleophile is the one that has the electrons looking for that positive charge. And those are analogous things. An electrophile is always the acid, Lewis acid. The nucleophile is always the Lewis base. Okay, hand up.
So my question is about the carbocation rearrangements. That's hard to say, sorry. So can it move more than one carbon away?
No.
Okay.
It's going to move once, and it's only going to go from a secondary to a tertiary. It'll never go from a secondary to a secondary. And once you have the tertiary, it's not going to move.
Okay.
So it's only going to move once. It's only going to move a methyl group or a hydrogen, or in the case of a ring, it'll actually move what seems to be more than a methyl group, but it's only going to go to a bigger or a more stable ring.
But if the tertiary carbon is 2 carbons away, it can't go there.
Correct.
Okay.
You have to move it from something just adjacent to it. Okay. How long do we wait until we know the score? Well, the top hat will have a raw score on there, but don't worry about that. Usually after everybody's taken the exam, I look at the different questions and which questions people got a lot wrong on. And so I'll make note of that to stress it more in there. So it's usually about 24 to 48 hours after that you'll know your score. In fact, after the exam, I'll also download all of your homework grades. And so within 24 to 48 hours, I'll have all of your grades in Canvas. And those are the curved grades, and all adjusted grades will be in Canvas soon. Okay. All right, hand up.
Yeah, I keep getting enantiomers and diastereomers mixed up because I thought enantiomers, like the non-superimposable, that means like they're mirror images, but not. I don't know. I guess I'm
Mirror
still confused.
images, but non-superimposable. So think of it this way. Enantiomers are one pair of 2 molecules that are kind of like your hands, where if you tried to overlap them, the finger and the thumb are now overlapping, but the index fingers, the hands and the wrists are overlapping just fine. So only 2 of the groups have swapped places. So they can't go on it. But if we look at them in a mirror, they're in the right place. So that's enantiomers. They only have 1 stereocenter. If you have more than 1 stereocenter, then you can have the diastereomers, and you draw the first one as a pair of enantiomers in just using the mirror image. And in the second set, you actually have to swap one of the centers and then draw its mirror image. Okay, so in diastereomers, you can have 3 or more compounds because of the 2 stereocenters. In enantiomers, you will only ever have a pair. Okay.
Okay, and then the meso is a direct mirror image, just complete.
Right. It's a mirror image somewhere within the compound that lets it not be chiral. Remember, a mirror image anywhere, and even though you may have wedges and stuff on and you might have 3 different groups, anywhere, if you find a mirror image anywhere in the thing, it becomes non-chiral or achiral, not chiral. Okay.
Okay, thank you.
Have a hand up.
So to kind of follow up with what she just asked, so in an enantiomer, that can have 2 stereocenters too, right? Or can it only have 1?
No, and an enantiomer is a pair of, so the simplest thing is 1 stereocenter, and they only have a pair of enantiomers, right? Because there's only 2 possible ways. Once you have more than 1 stereocenter, you can have that many sets of enantiomers. Okay, so you have, if you have 2 stereocenters, you can have up to 2 sets of enantiomers, because you can only do, 1 set will be a mirror image of itself, and the other set could be a mirror image of itself. So,
and that mirror image, though, could also be the meso compound.
correct. If one of the sets has a mirror plane in it, then it's meso. Yes.
Okay.
Now, if you had 3 stereocenters, that means you're going to have 3 pairs of enantiomers, And then you have to look at all the pairs and see if any of the other pairs have mirror planes to turn them into meso compounds or not. So if you only have one stereocenter, only look for the enantiomers. If you have more than one stereocenter, look for that many pairs of enantiomers and then look for mirror planes to see if you have meso compounds or not. Okay. Nicole, do you still have your hand up or?
No, I don't. No.
Okay. All right. Really good questions. Any more? Again, go over the homework, look and see what you got right and wrong. Go to the goals, look and see, make sure you have all those concepts really, really well. Could you please elaborate on how to differentiate moderate, weak nucleophilicity and obvious from strong cause the negative charge, etc.? Okay, I can do that. So what I try to do is make it so that you don't have to memorize as many things, that you can look for trends, right? And so in the case of nucleophilicity, which is right here, the trend we're looking for is, we can actually look at it as a function of where are the electrons? Remember, a nucleophile is something that's going to use a pair of electrons to create a new sigma bond, right? So if you already have a negative charge on your system, that's going to make it a good nucleophile, okay? Because you already have that pair of electrons that's giving you that negative charge to create that new. So notice all of our good ones have these negative charges, but the outliers there are the really tiny ions. Now remember, the reason those are not as nucleophilic is they're smaller and their electrons are held more tightly to the core, okay? Bromine and iodine are big and fluffy, so those electrons are way on the outside. That's why they're better nucleophiles. They're easier to be used to make those sigma bonds. Okay. So sulfur anions, oxygen anions, and our halogens, the big halogens. Okay. Notice nitrogen negative charges aren't here. The reason nitrogen negative charges aren't on this list is because they are too strong as bases. They are much, much stronger bases, and they rarely act as nucleophiles. They usually act as a base. So if we have a negative charge on our nitrogen, it's not going to be on our nucleophilicity scale. The next thing that's our moderates right here are recognizable because either they have a charge, but it's a delocalized charge, or that charge is really, really stable, like very nucleophilic, very small atoms, or the acetate ion. Because we are sharing that negative charge over two atoms, that negative charge is kind of happy. It doesn't need to use it to make that new sigma charge. And then we have the larger ones, the nitrogen and the sulfur here with lone pairs on. Okay, so neutral nitrogens and sulfurs are moderate nucleophiles.
So the more stable they are, the harder it is for them to give away electron pairs, right?
I don't want to say stable. I want to say the more willing they are to share those electrons. For example, the bromide ion is very stable, right? Because the bromide ion is a very weak base because it was a very strong acid. So it's very stable, but it's willing to share those electrons because it's further away from the outside to make that new bond. That's why it's a good nucleophile. So don't think of it as just ion stability. Ion stability just gets you there. Think about how willing it is to share.
It's just a willingness. Okay.
It's willingness to share electrons.
So if it's larger, it's more willing.
Correct. If it already has the charge and it's a large anion, it's going to be a good nucleophile. And then as we have a charge, but it's not as large or it's spread out, it's a moderate nucleophile. And then sulfur and nitrogen will be neutral, but still be good moderate nucleophiles. Notice that all of these poor nucleophiles down here all have oxygen on them and are all neutral. Okay. Does that answer your question? Will you be asking questions on the exam that aren't on the review, like chair confirmations? Well, maybe a boat and chair confirmation, but probably maybe. Just knowing boat and chair and which one's more stable, I think is important, but I'm not sure. So, could you review on how to determine RNS with your hand? That's a great one. So the first thing we need to do about that is, but if it's on the review, those are definitely going to be hit on the exam. I'm just not sure about the boat and chair. Okay. We need to remember when we're talking about RNS, our priority rules. So our priority rules, we have 3 priority rules, right? It's the atomic number. Higher atomic number always has thing. If you go over one and they have the same atomic number, what's attached to them? And then what's attached to them, the third rule is if you have double bonds, each of those bonds counts. So if you had 2 things bonded, if you had a double bond to oxygen, you have to count oxygen twice. So those are our priority rules. For RNS, you assign your material. You know, you can, I like to use my hand where I push it over there. Try to orient my hand such that the lowest priority group is where my wrist is, and then equivalently assign. So let's say, for example, let me go ahead and get to a blank right here. Okay, actually, let's go ahead and assign this one right here. We're going to look at this one right here. Okay, now, because there's a heavy wedge coming out with that OH group, that means that we have a dashed wedge where our hydrogen is, dashed wedge for our hydrogen. Okay, so let's do our prioritization. Oxygen is going to be number 1 because it's the highest atomic number. Then we have these 2 carbons, and we can't differentiate between those 2 carbons, but the carbon next to this one has an oxygen, which makes it a higher priority. So that's going to give us our 2. The other carbons are 3, and our hydrogens always are 4. Okay, so you can use either hand, and in this one, it would be easiest to use my left hand because I can put the hydrogen where the hydrogen is, it's pointing down, right? And looking at here, that OH group is pointing out at me. So I'm going to pick my thumb to be that OH. So my wrist is my hydrogen, my thumb is my OH, okay? That means the next closest carbon to me is going to be my index finger. And then the last carbon is going to be the furthest away from me, which is my middle finger here. So that means it's 1, 2, 3, 1, 2, 3. And now I turn it to look at myself, and it's looking as it's going counterclockwise. That means that that particular carbon has the S configuration. Okay, does that help? See, I like to, show you by, okay, this is the one pointing down. So we're going to orient my hand that way. The OH is pointing at me, so that's my thumb. And then I can assign the other 2 based on proximity, and then go ahead and orient so you can look straight down it. And you'll get it right most of the time.
Dr. Irving?
Yeah.
Because the hydrogen's already in the furthest position away from us, like going in, we have to, can't we just see that it's counterclockwise from the 1, 2, 3 like on the page? Or
you can, and occasionally I try to do that and I get it right most of the time. but I occasionally get it wrong, and so that's why I always use my hand.
Okay, so the hand's like more reliable.
For me, it's more reliable. If you play a lot of Minecraft, you probably can figure it out yourself, but without doing that. But for me, the hand is much more reliable. So for example, if we did it this way, where our 4 was out here and our 3 was here and our 2 was in the page here, so it's facing at me. So in this case, I would do my hand in this position right here, where my 4 is at my wrist, the 1 is going to be up, the 3 is going to be on my middle finger, and then the 2 is going to be my thumb. And when I rotate that back around, I have 1, and then my thumb was 2, so 1, 2, 3, so that's clockwise. So this one would be R. Okay, so that's what happens when you have the lowest priority group facing you. You orient your hand such that your lowest there, and you assign them that way, and then you rotate it around and look for counterclockwise versus clockwise. Does that answer your question? Okay. All right. So
just on the example that you did right now,
Mhm.
Can you go over it again? I got kind of lost.
Okay.
Like
Just this exact example.
yes, please.
So because that 4 is facing out at me, I want to make sure I orient my fingers correctly. So what I'm going to do is I'm going to hold my hand to where the number 4, which is going to be my wrist, is facing toward me and the others are facing away, right? Now, the one that's up is going to be my index finger because that's pointing up. And then the 2 is going to be my thumb because it's on this side of my thumb, and the 3 is on that side of my index finger, right? So I have 1, 2, 3. So then when I turn it back around, I have 1, 2, 3, 1, 2, 3, and it's going in a clockwise fashion, which means it's R. Okay?
Yes, that makes sense. Thank you.
All right. So, I mean, that's why I like this tool, because, you know, you can move your hand to whatever it looks like on the page and get your assignments correct. And then when you move it back to here, you'll always get your clockwise and counterclockwise correct. That's why I think it's a really valuable tool. Okay. Next question.
I'm sorry, so you said that if it's clockwise, then what does that determine?
The clockwise means it's rectus or R.
Thank you.
Counterclockwise means it's sinister and S. All right. Got about 10 more, no, got about 8 more minutes left in your time here. And so again, don't come to Zoom, go straight to Top Hat, look for that. If it doesn't pop up right at 11, go ahead and refresh your screen. That usually solves it. Try the mock exam. I've set it up so you have to show your ID and so that it's doing the screen recording. So hopefully that'll all work. Number one problem is not allowing screen sharing in one of your settings, and that usually fixes it. And there's a video on Top Hat on how to fix that with their help. Okay. Hand raised.
Does the exam kind of follow a pattern like the order of chapters, or are the questions all sporadic and?
I think it's assigned to do a random order. So I would expect them to be all mixed together. And again, the table of contents is at the beginning and the end. The only other weird problem I had on the test was that it wouldn't scroll down for some reason. It didn't like their mouse, and so you had to use the tab button to tab down. That's the only other thing I've seen. But for the most part, it's fairly easy to take this compared to like Examity, etc. All right, well, if there's no questions, what I'm going to do is I'm going to stop sharing and stop recording. And if you want to hang behind and ask a couple more questions, that will be fine.